Now let's solve a three-dimensional problem. First, let us read the problem. Our problem is 351. Cables AB and AC can sustain a maximum tension of 500 newtons, and the pole can support a maximum compression of 300 newtons. Determine the maximum weight of the lamp that can be supported in the position shown. The force in the pole acts along the axis of the pole. So we have the pole at point O. It can withstand a maximum load of 300 newtons. Okay, so we have two cords from A to C and A to B, and in fact each can carry maximum 500 newtons, and they can only carry tension. And we have a lamp here. So the distances are given from A to O to C is given as 1.5 meters, and so the axes are given also. We have the x-axis, we have the y-axis horizontally, and z-axis vertically. X-axis can be considered as towards us. So the height of the lamp from the ground is 6 meters, and the position of the lamp is 2 meters in x direction and 1.5 in negative y direction. This is where point A is. And let's look at the point B. Point B has a 0 in z direction, but 1.5 in y direction, and it is negative 4 in x direction. Okay, so first thing that we need to do is to find the unit vectors along AO, AC and AB. Now we know that the forces in AB and AC are tension, and AO is compression. Okay, let's find the unit vectors from A to C. Okay, so AC is equal to RC minus RA. So from here we can find the unit vector UAC. It is the RAC divided by its magnitude. If we do the calculation, what you are going to get is minus 0.04 I vector plus 0.06 J vector minus 0.122 K vector. So this is the unit vector from A to C. Next we will calculate the unit vector A to B. We will do it again identically. First it is equal to RB minus RA, right? So it is again minus 0.074 I vector plus 0.037 J vector minus 0.074 K vector. Okay, so this is from A to B. Now next thing is we will calculate the unit vector from A to O. So ROA is equal to RO minus RA. RO is 0. So it is 0 minus 0.047 I vector plus 0.037 J vector minus 0.142 K vector. So these are the unit vectors along the cords and along the pole. Okay, now let's draw the free body diagram. We have the weight. This one is the weight. So weight is downwards. It's okay. Now we have a force towards the pole, FAO. I just choose a direction. I don't need to know the direction. I just put an arbitrary direction, but for the forces in the courts, I know that they are tension, therefore they will pull this point. As a result, I have FAB in this direction and I have FAC for the other one. So let's write each forces in Cartesian form. So the weight is equal to minus WK. I don't know the value of W at the moment. This is my free body diagram, by the way. Now let's write the FAB. FAB is FB multiplied by UAB. FB, I assume that the FB is the magnitude of the force along AB. Now let's write the FAC. FAC is equal to FC multiplied by UAC. I assume that FC is, I denote the force in the chord AC with FC. Okay. Now FAO, I assume that the force that goes to the pole is FO. So the magnitude of the force, of course. So FO multiplied by UAO. Okay, so sum of the forces in x direction has to be equal to 0. Now, of course, I have UAB, UAC, right? Each has x components. From here, I can easily obtain that minus 0.074 FB minus 0.04 FC minus 0.047 FO is equal to 0. This is my first equation. Now I know that sum of the forces in y direction has to be equal to 0. So basically I will sum up the j components. So this comes from the I components of the forces. Now I will continue with the j components or components or y components, forces in the y direction, the components of the forces in y direction. I will sum them up. So it is 0.037 FB plus 0.06 FC plus 0.035 FO has to be equal to 0. And from here I have the z component of the forces has to be equal to 0, and then I will have minus 0.074 FB minus 0.122 FC minus 0.142 FO is equal to W in this case. So it's not equal to so this is minus. It's my mistake. Okay, so it is minus 0.074 FB minus 0.122 FC minus 0.142 FO minus W is equal to 0. Now I have three equations. Okay, and I need to write from here. I can solve FB, FC and FO, okay, by means of W, either by using back substitution. So what's back substitution? I can take out the FB from here, for example, from the first equation, and substitute the value into here. Now I will be left with FC and FO, and then I can take out the FC by means of FO in this from the second equation, and I will substitute it into this equation. Certainly I have FB from here. As a result, I will be left with the FO in the third equation and W. Therefore, I can write the FO by means of W. After calculating the FO, by using the back substitution, I can calculate the FC by means of W. So I will substitute the value of FO by means of W into this equation. So remember that it is only left with FC then. So I can calculate the FC by means of W, and then by using the third back substitution, I can substitute FC and FO, which I have calculated by means of W, and I can obtain FB by means of W. So remember that FB and FC are tensions in the cord, and FO is the force which comes to the pole. So W is a positive quantity because of the choice of our direction. We know that it's positive. Therefore, FB and FC are positive, we can say it, and FO is negative because it is compression. Now, from these equations, I can calculate W by means of FB, FC, and FO. Okay. Now, W is equal to FB divided by 6.75 from the first one. So remember that FB can take maximum of 500 newtons divided by 6.75, and from here I will obtain 74.074 newtons. If I do the same thing from the relationship between the weight and FC, I will obtain this value. So the maximum value for FC is 500 newtons, and that gives me 122.25 newtons. And at last I have the weight by means of FO. So I just take the absolute value in this case. So I omit the negative sign here, and I calculate W as FO divided by 14.08. So FO can be maximum at most 300 newtons. Okay, so if you divide 300 by 14.08, what you are going to get is 21 sorry, this line is not, should be here. Okay, 21.3 newtons. So if I look at the final values, the values are like this. If FB is maximum, so the weight can be 74.074. If FC is maximum, it is 122.25. If FO is maximum, then the value of the weight is 21.3 newtons. So certainly, of course, the minimum value that I find for the mass will be the maximum value that can be carried by the system. So the weight of the lamp can be 21.3. Okay, so this is the maximum weight of the lamp that can be carried by this structure.